Good morning, students. Let's start the session. Let's start the today's session with the flow chart. We'll continue with the next topic of our syllabus, which is the flow chart. Now, why we need this flow chart? The flow chart, suppose if someone needs to explain the solution of a problem, if someone needs to explain the solution, if someone needs to explain the problem, then he needs to explain that what are the steps he has followed to solve a particular problem. So the sequence of those steps, the collection of the sequence of those steps is known as an algorithm, which we'll discuss later on. So to represent that algorithm in a pictorial way, like if we have the pictorial representation of the algorithm, then we can understand that algorithm in a better way. So for that purpose we use flowchart. Flowchart is what? Flowchart is the pictorial representation of a sequence of steps, means of an algorithm. So what the flowchart is? Flowchart is a pictorial representation of the sequence of operations necessary to solve the particular problem. If suppose somebody is explaining the things, then it could be quite effective, it could be quite understandable if he or she is explaining the things with the help of some pictures, with the help of some blocks, some flow of data, that from where the input is coming from, at what point the output is generated. So that pictorial representation is quite understandable. So for that purpose we use flowchart. The pictorial representation can also give the better understanding of step-by-step solution of a particular problem. Now in explaining that algorithm in a pictorial representation, we need to follow certain boxes, we need to draw certain boxes, we need to show where the flow of our data from which box to which box. So we need to draw certain boxes. So first we'll understand, before drawing the flow chart of a particular problem, we need to understand about each and every box. So first box is terminal box, which will represent the start and end of our program, of our solution, of our flow chart. So from where we are starting and at what point we are ending our solution will represent with the help of this terminal box. Now after the terminal box, if we are following some computational steps in our solution, like we have solved a particular problem, and if in that solution we have written some computational steps, like we use some arithmetic expressions, we use some other expressions, then we can write those processing blocks in this process block. Now the next block is input and output box. For solving a particular problem, a solution of a particular problem contains some inputs, because for solving a problem we need to have certain inputs, and after the solution we have generated with certain outputs. So to represent those inputs and outputs, we need to draw an input and output box. sometimes we need to follow the decisions. Then if this condition is true, then we'll go to this step. If some condition is false, then we will go to this step. So in that particular manner, in that particular case, we will draw decision box. Decision box will produce certain branches. Decision box will produce certain branches, because if the decision is true, then we will follow something. If the decision is something else, we will follow something. Only that case we will use decision box. We will see when we draw the flow chart of some problem that where to use this decision box. And now if we are suppose using the decision box, and for one particular output we are following certain steps, for one particular output we are following certain steps, but at the end if we need to connect those, at the end if we need to we need to show the projection of the output of both these different procedures to one end, then we need to connect those outputs with the help of connectors. So connector, what the connector will have? Connector will have the two lines coming from the top, and the output of the connector is a single line. Then at last we have some flow lines, which is very important while drawing the flow chart. The arrow is very important while drawing a flow chart. Sometimes people draw the flow chart without mentioning the direction of the arrows, or sometimes they draw these lines in an undirectional way. So that is very wrong way to represent the flow chart, because flow chart must have the flow of a data from one block to another for better understanding. So these are the blocks we can use to construct a flow chart. Now come on to the section that what are the other advantages of flow chart. So these are the advantages of flow chart. I'll explain you the advantages of the flow chart, that if we have the pictorial representation, then what are the benefits we can have? We can understand the problem in an easy way. It is the better way to understand the problem, because once someone is explaining by drawing some blocks, by discriminating the statements, because in the flow chart we can discriminate the statements. Some statements can be written in one block, some statements can be written in different block. So we can discriminate between different statements. So it is quite easy to understand. It is quite easy to find an errors in our program, that in this particular block we have an error. So this block is of this type. So these statements are of this type. So fixing of those errors is also quite easy while making the flow chart. Flow chart is also helpful in maintaining the problems of our operating system. The flow chart acts as a guide or blueprint. When we draw a flow chart of some particular solution, it can guide us very well. It will show the blueprint of a solution. It will show the blueprint for the complete solution of a problem. So we can understand the solution of a problem in a better way with the help of flow chart. But apart from this, apart from all these advantages, the flow chart has some limitations also. In those limitations, suppose if we need to change some steps in our flow chart, Suppose if we need to change some steps in our flow chart, then we need to redraw our flow chart, because the blocks of the flow chart cannot be typed, so we need to redraw it. We need to redraw those. If we are suppose adding one process box in between, if we are adding one decision box in between of certain steps, then we need to redraw our flow chart. And for a large problem, for a big problem, the redrawing of a flow chart is a complex task. For a very complex problem, drawing a flow chart is a complex thing. So these could be the limitations of the flow chart, because redrawing of something can consume more time. Now this is all about the flow chart, the theoretical concepts behind the flow chart, what are the boxes we use in the flow chart, what are the advantages of the flow chart and the limitations of the flow chart. Now come on to the problem that we need to draw a flow chart that of the given number is odd or not. We need to find out that the given number is odd or not. We need to draw a flow chart of that. Now we'll see the solution of this question step by step, so we can easily discriminate about the boxes, how we can use those boxes and where to use those boxes, so that we can easily draw the flow chart of any problem. Now we need to find out that the given number is odd or not. For that purpose, we need to have a number. So first we will start the flow chart with the help of a start and end box. After starting, what we have, we must have a number which we need to check that whether this number is odd or not. So we must have that number. So that number will be an input. So we will write that number in an input and output box. We will read the input. Here that number is in A. We read input A. So that must be written in the input and output box. Now we need, for odd and even, we need to do certain process. That process is we need to find the modulus of that number with 2. If it is 0, we'll do the certain thing. If it is 1, we'll do the certain thing. So we need to write a process, A modulus 2. So because it is a process, we will write it into the process box. We will calculate the output of this process, and then we will check in the decision box whether this number is 0 or 1. Because if the number is 0, we have one branch. If the number is 1, we have another branch. That's why we will write the decision box here. And in the decision box, if it is yes, then we say that number is even. Now even and odd is an output, so we will write even and odd in the output box. Now the output box will produce one output. Those outputs will be connected, because the end of a program is a single line. So we need to connect those outputs and convert it into the single line. So we have connected these two outputs with the connector and find one ending of a program. So this is the solution of a problem of odd or even number with the help of flowchart. Now the next question is for practice. I'll explain the answer of this the flow chart of this question. You can draw it by your own. We need to draw the flow chart to find the largest number in the given three numbers. So again, first we will start the process with the start and end box. Then we must have three numbers because we need to compare the three numbers. So we must have the three numbers. So those three numbers must be an input. After taking the input, we will compare these two numbers. First, suppose these three numbers are A, B and C. First we will compare A to B. Then we will have two different branches in the decision box. One branch is for A is greater and one branch is for B is greater. Now if B is greater, then B has been compared with A. So we should compare it with C. And if A is greater, then A has been compared with B. So A should be compared with C. And in both the cases, we will produce some outputs. Either A is greater, C is greater, B is greater and C is greater. And then we will connect each and every output of a box with the help of connector and we'll get the final solution. So everybody will try this question by their own. We'll quickly move on to the algorithms. So earlier we have seen that we were talking about the pictorial representation. But of what thing we are drawing that pictorial representation? We are drawing that pictorial representation of an algorithm actually. So we need to understand that what that algorithm is. An algorithm is a step-by-step solution of a particular problem. Step-by-step solution, what the step-by-step means? Suppose we need to follow 4 steps. If we'll change the order of those steps, then there may be a possibility we cannot get the output. So the order must be maintained there. We need to follow certain step-by-step solution. Order must be maintained to get the desired output. That those steps are known as the algorithm of a program. Now what is the scenario? How we can say that this algorithm is good? First thing, finiteness is very important. What is finiteness? An algorithm must terminate after some finite number of steps. Means we are writing an algorithm and we are writing some infinite number of steps, then we cannot get the solution after those infinite number of steps. Because we must get the output somewhere. So what we required, we have some finite number of steps which we need to follow to get a certain output. So that is known as finiteness. If the number of steps are infinite, we can never get the output. Second very important characteristics of a good algorithm is definiteness. Every step what we are writing, every step must be clear and understandable and unambiguous. Right? It does not mean that there must not be a scene that we have written with 2 statements and both are the 2 statements are generating the same output, but they are 2 different steps. So we must be unambiguous about that which step we need to write first. So every step must be very clear. We must be very precise that in this step what the output is coming, in this step what the output is generating. Now the third thing is, which is very important characteristics of an algorithm, is an input. We can take either 0 or more inputs, but every algorithm must have some outputs. Effectiveness of an algorithm is very important. An algorithm should be effective. That means whatever the operations we are performing in an algorithm, those operations must be understandable, those operations must perform in the finite length of time and should be programming language independent, because when we write an algorithm, see, in an organization, when we write a project, when we write a code, then the algorithm team is different. So there may be a possibility that person who is writing an algorithm does not know the coding part, because it's not the part of an algorithm team. Algorithm team needs to just write the step by step solution. Coding team will code each and every step to get the solutions. So these are the characteristics for the good algorithm. Now we will discuss what are the types of algorithm in computer programming languages. See, in detail, you will go through with all these types of algorithm in detail later on in different subjects, maybe possibly, or in this subject possibly. But here we will discuss in a short manner that what these types of algorithm are actually comprised. So the type of algorithms, the first type of algorithm is the recursive algorithm. I'll tell you about these algorithms independently with the programming language concept, because till now we do not have the concept of programming language. So I will tell you the concept behind these types of algorithms in a theoretical manner. Okay, so the recursive thing is, if suppose we need to perform a same task, repeatedly again and again. See, I am talking about the same task. If we need to perform one particular task again and again for certain times, that is again very important, not for an infinite number of times. If we need to perform a certain task for finite number of times again and again, then this type of process is known as, this type of algorithm is known as recursive algorithms. Clear? Just take an example of when we write a table of certain number, then the same step we need to follow again and again by changing one simple small input. 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3. The same multiplication operation we are applying again and again. So this could be a recursive algorithm. The second thing is the divide and conquer algorithm. Now divide and conquer is what? Conquer means solve a problem, solution of a problem, solving a problem. Dividing is dividing a problem. Suppose we have given with a large problem, the solution of which is not possible, or the solution of which is very complex. So we will divide that large problem into small sub problems. Into small sub problems. Then we'll separately solve these sub problems. That step is known as conquer. So first we'll divide the whole problem into small sub problems. We'll separately solve each and individual sub problems, each sub problems individually. Then we'll combine the result of each the problems and we'll get the final solution of that large problem. So this type of algorithm is known as divide and conquer. Now the next type of the programming algorithm is the dynamic programming algorithm. In this we need to follow the dynamic scenario, like we'll get the solution on the basis of, suppose we are following some 10 or 20 steps, then after 5 steps we'll check the solution. On the basis of that solution we'll decide the further steps, we'll decide what are the other steps we should follow. So on regular outputs, if we are changing our steps or if we are deciding our steps, what would be the next steps, then these types of algorithm is known as dynamic programming algorithm. And the next type of algorithm is the randomized algorithm. These are also the special type of algorithm in which we are depending upon the random solutions of the problem, will decide the particular solution of a problem on basis of the random solutions. So you will be studying about all these types of algorithms maybe in this chapter or maybe in some another chapter or another subject. So this is all about the algorithm, that what the algorithm is, what are the characteristics of the good algorithm, and what types of algorithm we are having in a computer languages. Now we will understand how to write an algorithm. In the same way as we have discussed how to draw a flow chart of odd and even number, so now we will discuss how to write an algorithm for the same problem. So again, for algorithm we again need to follow some steps. Like an algorithm must have start and end point. So the first step will always be start. We have started the algorithm. For odd and even number, for checking what we have, we must have an input number. So the next step which we need to follow, we must have that number. So in the second step, we read the number which is to be checked. Let that number is A. Now step 3 is, we will calculate the remainder of A with 2. That will be the step 3. And if then in the next step we need to check the value of that remainder. In one step we will saying that the value of the remainder is 1, then we'll follow some step, and in the another step we say that the value of the remainder is 0, then we need to follow some another step. In both the steps we are producing output. So when the output has been produced, we need to write the end of an algorithm. So in the step 6 we have written stop. So this is the way in which we can write an algorithm of a program. So we must be very sure while writing an algorithm. Suppose we have one problem here. Draw the flow chart. So we can write an algorithm also of this problem. How we can write the algorithm of this problem? Again we'll take the input, 3 inputs. We'll compare in between those 3 inputs. And after that, we'll come on to some solutions. We need to follow those steps sequentially. If that sequence is very important. Suppose if we do not read the number first, then how we can calculate the modulus it with 2? So the sequence of the steps is very important for solving a problem. So this is the scenario which we have discussed today. We have discussed about the flow chart, what the flow chart is, why we use flow chart, what is the reason behind using flow chart, what are the blocks we used in the flow chart, what are the purpose of each and every block, what are the advantages of drawing a flow chart, what are the limitations for the flow chart. We have also seen the things that how we can draw a flow chart of a solution of a problem. Then we have discussed about algorithms, its characteristics and its types. Now see, before writing a C program, there may be a possibility. Suppose what I told you, that in an organization, algorithm team and the C programming team is different. So there may be a possibility that the team which is writing an algorithm must not know how to write a code, but the team which is writing a code must definitely know about the algorithm. Because before writing an algorithm, we cannot write a C program. This is very important to understand, because from the next chapter we'll continue with the C programming concepts. So it is very important to understand that before writing a C program, we must be very clear about how to write an algorithm. Because if we do not know about these steps, suppose step 1, step 2, step 3, 4 and 5 and 6, then how we can write a code? We know the language, suppose we know the C language, but we do not know how to calculate the modulus. Then how we can write the code of that solution? So this is very important to write an algorithm first, because once we understand the terminologies of C language, the concepts of what are the things you can use in a C language, even after that also, for making the solution of a program, it is very important for us to know how to solve that problem. If suppose we need to write a C program to add two numbers, and if we do not know how to add two numbers, we can never write a C program. So to understand about the C programs, we need to be very clear about, so for writing the C program, because maximum number of times I have seen that people are saying that, sir, I have a problem that I cannot go further in this program. I do not know what to do. I know what to write. I do not know what to do. Now we can write. So basic concepts we need to be very clear. So before coming into the next session, we should be very clear about the programming environment. We should be very clear about the flow charts. We should be very clear about an algorithms. So practice for an algorithm, for some couple of algorithms. Only after practicing you can write an algorithms, and only after understanding about writing an algorithm you can understand about how to write a program. So we have discussed till yet about the precedence and associativity, which is very helpful in calculating the final solution of the expressions. In writing a program also, this is very important. So in the next chapter, in the next lecture, what we will understand? We will understand about how to write a C program and how to execute a C program. See, as we have discussed that C program will be written on an editor. There will be an editor on which we will write a C program. That editor must be connected with some compiler. That compiler will convert my program into something, and it will generate some output. So in these two lectures we have studied about the basic things which is helpful for understanding of C program. Now I have also told you that we will discuss one data type table. See here, this is data type table. So in the next lecture we will understand what are the data types we will use. We will discuss this. We can discuss this particular about this table in this lecture, but first it is very important to understand about flowchart and algorithm. Now we are coming on to the concept of C language. Then first we will discuss the data type, then we will go with writing and execution of a C program. So in the next lecture we first will start with the data type. What are the data types? What types of data we can store in a C program? What types of data we can take in a C program? And if we take some data, then what it means for that particular program. If we take some variable as which represents some kind of data type, then what it means, what are the values that variable is having, what are the format that variable is having. So we will discuss about this, because data type is a very important concept in C. In every program we need to take the data types, because whatever we are using in a C program, whatever we will use in a C program, we must tell the compiler that this is this particular thing. Because if we will not tell the compiler, compiler will never understand what that thing is. If we will not tell the compiler what type of data of this variable is, then compiler will never understand and it will give an error, because it will not be having any kind of information about that variable. Because when we are representing one data type, that data type is having certain information. That data type must be having certain information attached to it. So we must be very sure that every data what we are using in a C program must be declared. We must tell the compiler about the type of data, and how we will tell the type about the type of the data to the compiler. That is another scenario, that is again a very important concept of C language, which is known as the declaration of that variable. A variable can be of any data type, but we need to declare it in the starting. So all these things we'll discuss in the next lecture. Meanwhile, whatever we have studied about precedence associativity, about algorithms, about flowcharts, about programming environment, about compiler, interpreter and assembler, you can explore about the compiler and interpreter. You can write an assignment also, that which one is beneficial, which one is fast. You can just explore and check that which functioning is fast, compiler is fast or an interpreter is fast. We will discuss this also later. First you will explore this by your own. We will discuss it, all these things in the next chapter. Till now, thank you.